All right, so we're talking about ellipses here. So remember, we're still in this idea that we have a cone and we are going to cut a cone. But instead of cutting it flat across the cone, what we're going to do is kind of cut it at a diagonal. So what that really does for us then, instead of it just being a circle, it cuts what we call an ellipse, right? Some might call it an oval, but the actual algebraic term for it is called an ellipse. Now, what is an ellipse instead of a circle? So if this was a circle, it would have a center and it would have a radius going to the, like what we'd call the width, and it would have the exact same radius going to the height, right? So that you could go here, it'd be a radius. If you go here, it's that same radius length. Now, an ellipse is going to take on one of two shapes. It is either going to be a circle that has been stretched along its x, right here. So that will be longer than this, what we can kind of call radius. So like imagine a circle and pulling it apart. And so whichever side becomes the longest, right, that is what we're going to call the major axis. And then the other one, since it is smaller, it will be called the minor, right? So sometimes called the major radius and the minor radius, or the major axis and the minor axis, right? So that you kind of hear those words, but major and minor. But since that can be the case, sometimes it might be stretched up and down. So again, we have, a distance here and here that is the same, and then a distance here and here that is the same. But same idea then, but now the major happens to be along the y, in the y direction that we call it, right? And the minor happens to be in the x direction. And I call it x and y because that's kind of how our axis runs, right? Now a circle is an ellipse, but it's just its major and its minor happen to be exactly the same. That's really the only difference between these guys right here. But since that's the case, what are we looking for an equation? Because this is what we're trying to get to of an ellipse. Oops. There we go. So the equation of an ellipse. So kind of like a circle, right? So imagine, if you will, here's, you don't have to write this down, but let me give you a reminder. Circle, it's x minus a squared plus y minus b squared is equal to the radius squared, okay? So imagine if I were to divide everything by r squared. So I'm talking everything that I see by r squared. What you would end up with would be x minus a squared plus y minus b squared over the radius squared over the radius squared is equal to 1, right? And then notice that the numbers on the bottom of each fraction would be the same, hence a circle. So we never just leave it like that. What we end up doing then is multiplying by radius squared, so that's going to go all the way across here. So then it cancels those. But then you got to also multiply this by radius squared. Hence, the formula gets back to this right here. All right, so that's the idea of a circle. But again, notice that the bottoms have the same number. Here is what we're going to do here. We're going to call it an ellipse. So the equation for an ellipse is, ready for this? X minus a squared plus y minus b squared. But then we are going to put this over some numbers. And so they can use all different kinds of variables that they want. Let's just call this k squared, and let's call this one over here h squared is equal to 1. So what we're going to do is kind of get that forced circle equation here where we make it equal to 1. This will always equal 1 right now. Now again, what do we need to know? We need to know that these two numbers will not be the same if it's going to be an ellipse. will not be the same, okay, to be an ellipse. So then, how do we identify? Here's what we know. We know that the center of an ellipse is very much like the center of a circle. So it will be whatever the opposite of that is, right? That minus a, whatever comes after the minus, right? So then we would say, oh, well, the center is at xa, and y is a b value. Whatever that value is, right? AB, it's gonna center the ellipse. And then we got to figure out the major and the minor, right? So the major, and let's just call this radius. And I know it's not a true radius, but it's the idea of what a radius would do. The major radius and the minor radius. Well, how are we going to know which is which? Well, these numbers right here, the K and the H, will depend on which one is bigger. The bigger of the two tells you which direction to stretch and how far to stretch it, right? So the major radius will be the bigger of K or H, and the minor will be the, oh, I totally misspelled minor, or radius. It'll be the smaller of K or H. And so what that's going to do is just going to tell us how far we stretch. Now the question is, do we stretch left or right, or do we stretch up down? Well, that depends on what which one this is under, right? So if the major is under the x, let's say the major was there, then we're going to stretch along the x or parallel to the x. And then that would make this one the minor. So then the smaller stretch gets there. So let me give you an example real quick, and then we'll jump right into some questions here. Let's say they gave us the equation x minus 3 squared on top, and then we had a y minus 1 squared on top. And then let's say this was 25, and let's say this was 9, equals 1. So again, it needs to equal 1 in order to be an ellipse formula. And these two numbers down here had better not be the same, because if they're the same, we're actually looking at a circle, because we're going to stretch the same distance left, right as we are up, down, right? So recall that. Okay, here we go. If this is my equation, let me hand draw a nice little graph here. And we're going to go, okay, center first, right? So x minus 3, that means move over to the right 3, and y minus 1 means move up 1. We just found the center of our ellipse, okay? Now, I'm going to take a look here. Which number is bigger, 25 or 9? Well, of course, 25 is. So we're going to square root 25. That's going to give me 5. So I'm going to go 1, 2, 3, 4, 5. To the left, 1, 2, 3, 4, 5 to the right. And that is where we're going to put our 2 points. So that is what we call the major radius, or the major axis, right? But the major radius is 5 to either side, left or right. Why is it left or right? It's because it is under the x. Now let's do 9. Square root of 9 is 3. So this one we're going to go 1, 2, 3. We're going to put a point. I'm going to go down 1, 2, 3. I'm going to put a point. Right? That's the minor axis. It's the square root of that, right? Why do I go up and down? Because it's underneath the y, right? It kind of tells you where we're doing it. And then we're going to connect these things, right? So kind of give it a somewhat of an arced looking shape here, right? It's a stretched circle. That's what it is. Or it kind of looks like a football or a rugby ball or something like that, right? That's what it looks like. So it's a circle that's going to go up 3, down 3, because that's the stretch on the y, the square root of that. And then I'm going to go over 5 and over 5. Why? Because it's the square root of that. So we got center, and we got the stretch on these things. All right, so those are what we are focused on for this ellipse shape. Where do I center it? How far do I stretch it? Now, there are other things on an ellipse that are called the foci, or the focus points, and there's vertices, and there's all kinds of things like that. But we are just going to be focused on the center and kind of the radius, the major axis and the minor axis, or the radius of these things here. Okay. So let's take a look at a few of these different things. What is it? We talked about that. What's the standard equation? We got that. All right, so here we go. Vertex, co-vertex on that one. So these are a center of 0. So when they say in vertex, so let me just give you a quick little look at this. So the center we already know is at 0, 0. So that's going to be here. So the vertex, we got 1 and -9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So they're saying there's a point out there, and the covertex is 0, 7. 0, 1, 2, 3, 4, 5, 6, 7. And there's a point there. Now, what they're not telling you is that these are mirrored. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right here. 1, 2, 3, 4, 5, 6, 7. Right here. So they're really saying that we have these, the covertex and the vertex. So it's going to just give us enough that we could know that everything is going to be mirrored on this. Okay, so what do we need to know? We need to know that this was 7. So that means dropping down is going to be 7. Going to the right would have been 9, because going to the left is also 9. So now we know that our major radius is 9 and our minor radius is 7. Okay, so let's try to put together at this. So now remember, our center is at 0, 0. So really it's x minus 0. Then we have a y minus 0. And we're going to square those. But now let's put them over their things. Okay, so since we stretched along the x's, we're going to take 9 squared and give it 81. And since we did the minor stretch along the y, that's the smaller number. 7 squared is 49, and it should equal 1. But at the end of the day, x squared over 81 plus y squared over 49 equals 1. That cleans it up real nicely. Okay, let's try this one right here. Actually, we're not going to try this one because this one has the focus value, and right now, just for the sake of time, we're not going to talk about focus of an ellipse. So I just want you to know how to do this type of ellipse. Okay, so let's graph each ellipse here. Let's kind of take these in order. Here we go, number 8. So I probably won't do all of them. I'm just going to do a couple of them for you. All right, what do I notice? There is no shift to the center, right? So you see it's x squared and y squared. That means that those are both minus zeros on them. So let's just put a big old dot right in the center, right? So now we got to think about, are you going to stretch more on the x, or are you going to stretch more on the y? Well, it's going to be the y because it's bigger, right? 81. Take the square root of 81. What do we get? 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's put a big old point. So that means you're also going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. Put a big old point, right? Okay, so let's now look at the x. Now the x, square root of 36 is 6. So that's 1, 2, 3, 4, 5, 6. That's our minor radius. 1, 2, 3, 4, 5, 6. That's the minor radius. And connect the dots. Okay, so an ellipse is the cousin of a circle, right? We just happen to be stretching. We just happen to be stretching a little bit more on the y and a little bit less on the x. Now, a circle is evenly stretched in its y direction and its x direction, right? So that's the only difference between that and a circle. Okay, let's take on number 11 here. Whoa, let's try again. Number 11. Let's build this little fashion there. Okay, so this one does have a shift off of 0, 0, right? Because I can see here and here, I can tell that we are shifting. So remember, it's always, you think opposite of what you see. Okay, shift left 1 and shift up 1, 2, 3, 4, 5, 6. That is where the center is going to be. Now, are we going to stretch more on the x or the y? X, because a 64 is bigger than 9. So Square root of 64 is 8. 1, 2, 3, 4, 5. Oops, sorry. Let's try that again. We're stretching on the x. 1, 2, 3, 4, 5, 6, 7, 8. Point. Go the backwards. 1, 2, 3, 4, 5, 6, 7, 8. Put a point. And then, since 9 is smaller, that makes it the minor radius. Square root 9 is 3. 1, 2, 3. 1, 2, 3. And we're good. Let's just connect the dots. Go through, and same here. Okay, so that's what these are called. All right, just a quick reference point. Anything on the edge, we call these vertices, okay? Vertices, right? Or sometimes called the shared vertice. So it's a vertex point, but co-vertices and vertices, right? So sometimes you hear that. There's other words called foci or focus points. These are just things that you might see in there. Don't worry about it. What we are worried about is major versus minor, and we're talking about that. So my major length, right, is a total of 16. My minor length is a total of 6. But how do we get that? It's by square rooting these numbers and doubling it because it's a radius. You're going to go both directions from the center. All right, so take that into account. What you need to know is the equation of your ellipse, how to find its center, how to shift it, and what your major and minor radii are.